You've probably heard about the MG42. Maybe you've seen it in documentaries, video games, or war films. Everyone talks about how fast it fired. That terrifying buzzsaw sound that echoed across battlefields. But here's what most people miss. The MG42 didn't just shoot faster than everything else. It fundamentally changed how armies thought about firepower, squad tactics, and weapons manufacturing. And the wildest part, over 80 years later, modernized versions of this World War II weapon are still in active military service around the globe. Let me take you back to the beginning, because understanding the MG42's revolutionary impact requires understanding the problem it was designed to solve. After World War I ended, machine guns had proven themselves as absolute game changers in modern combat. The age of cavalry charges was over. These weapons were here to stay. But Germany faced two major obstacles as they looked toward the future of warfare. First, the Treaty of Versailles had slapped them with severe restrictions on weapons development. The victorious Allies blamed Germany for the war and wanted to ensure they couldn't up military might again. Of course, this didn't actually stop German engineers. They simply worked under code names and then partnered with firms in other countries where the restrictions didn't technically apply. Where there's a will, there's a workaround. The second problem was more fundamental. German and military strategists were envisioning a completely different kind of warfare. They'd lived through the nightmare of trench warfare on the Western Front. Those grinding, bloody stalemates where armies barely moved for months. They wanted something new, fast, mobile, aggressive tactics that would eventually become known as blitzkrieg or lightning war. The machine guns they inherited from WW2 simply didn't fit this vision. Take the MG08, Germany's version of the water-cooled Maxim gun. This beast required a crew of at least 5 soldiers to operate effectively. With water, tripod, and all the necessary accessories, it weighed over 100 pounds. Try running that through a rapid advance. It wasn't happening. So German engineers, working in secret, began the journey toward creating something revolutionary. Their first attempts at creating lighter, air-cooled machine guns ran into immediate problems. Early versions like the MG42 used magazines that held only 25 rounds. That's roughly 2 seconds of continuous fire before you're reloading. They also experimented with 75-round drums, but these proved unreliable in combat conditions. The engineers kept pushing. But they weren't just trying to make a lighter machine gun. They had a much more ambitious goal: creating what we now call a general-purpose machine gun, or GPMG. Think about it this way. Most armies had different weapons for different roles. Light machine guns for infantry, heavy machine guns for fixed positions, vehicle mounted guns, aircraft guns, anti-aircraft guns. Each required different training, different ammunition systems, different maintenance procedures. The logistical nightmare was immense. the Germans ask, what if we could design one excellent weapon that could fill all these roles? One gun that could be quickly configured for any mission, mounted on tanks, vehicles, or aircraft, used against ground targets or low-flying planes, deployed in light mobile configurations or heavy defensive positions. And they succeeded. Enter the MG34. This weapon, which often gets overshadowed by its famous successor, was actually the world's first true general-purpose machine gun. It featured reliable belt feeding, a significant innovation, and a quick-barreled change system that allowed sustained fire. When the MG34 first appeared on battlefields during the Spanish Civil War, which Germany used as a testing ground for new weapons, no other nation had anything remotely comparable. The Allies were caught completely off guard. Nothing in their arsenals matched this versatility and firepower. But even with this achievement, German engineers weren't satisfied. The High Command wanted improvements, particularly in two critical areas: production cost and manufacturing speed. Here's why. The MG34 was a beautifully crafted weapon, but that was part of the problem. It was built from precision, milled steel parts with tight tolerances. Each gun required skilled labor and approximately 150 man-hours to produce. It wasn't cheap, and those tight tolerances meant the weapon could be finicky in dirty or freezing battlefield conditions if soldiers didn't maintain it meticulously. As World War II evolved into a war of attrition, where victory depended on which side could produce and outlast the other. These limitations became critical weaknesses. Germany needed something they could manufacture quickly and cheaply without sacrificing performance. What happened next seems almost impossible. German engineers were tasked with creating a better machine gun while simultaneously cutting production time and cost in half. Most people would call that an unrealistic goal. They achieved it. The MG42 represented a complete reimagining of machine gun construction. Everything that could possibly be made from stamped sheet metal was stamped, rather than milled. This wasn't a cost-cutting measure that reduced quality. It was brilliant engineering that actually improved battlefield reliability. The weapon used a short recoil roller locked action that enabled even higher rates of fire than the MG34. The looser tolerances meant it actually performed better in realistic combat conditions. SNOD. Extreme temperatures than its more delicate predecessor. Let's talk about that rate of fire, because it was genuinely shocking. The best machine guns the Allies fielded fired around 600 rounds per minute. The MG42 doubled that at minimum, typically achieving 200 rounds per minute, with some configurations reaching 500 rounds per minute, depending on the ammunition and bolt used. To put that in perspective, that's 20 to 25 rounds per second. The sound wasn't like other machine guns. It was a continuous ripping noise, like tearing fabric at impossible speed. Allied soldiers called it Hitler's buzzsaw. for good reason. The barrel change system was simplified and accelerated. Instead of the MG34's method, unlatching and twisting the receiver, then extracting the barrel from behind, the MG42 used a simple side latch. One hand could pull out the hot barrel and slap in a fresh one. A well-trained crew could complete this in about 4 seconds. There was a trade-off, of course. With 20 rounds screaming through the barrel every second, gunners only had a few seconds of continuous fire before risking overheating. Barrel management became a critical skill. Interestingly, the MG34 remained in production throughout the war specifically for use in German tanks. The MG42's side loading barrel change system would have required completely redesigning tank interiors, so they stuck with the 34 for vehicle use while the 42 dominated infantry roles. The MG42 first appeared on the Eastern Front in late 1941 for field testing. The Germans liked what they saw. Official adoption came in early 1942, with the first major combat deployment happening in North Africa with Rommel's Africa Corps. It didn't take long for panicked reports to flood into Allied intelligence offices. The British 8th Army encountered the MG42 in North African battles and immediately recognized they were facing something unprecedented. That distinctive firing sound was unlike anything they'd heard. It was terrifying, but the impact went beyond just having a faster firing weapon. The Germans had restructured their entire infantry's quad organization around maximizing the machine gun's effectiveness. A standard German infantry squad of 10 men was built like this: a 3-man machine gun team consisting of gunner, assistant gunner, and ammunition bearer, plus 1 squad leader and 6 riflemen armed with Kar 98 bolt action rifles. The rifleman's primary job wasn't to be the main source of firepower. It was to protect the machine gun team and keep them in action. This was completely backwards from Allied squad organization, where riflemen provided primary firepower and machine guns supported them. The Germans made the machine gun the center of everything. Squads were even issued pack animals, donkeys or horses with carts, to haul ammunition, because they needed a lot of it. Even their ammunition cans were ingeniously designed. Unlike Allied ammo cans, German containers were watertight with clever folding handles positioned so a soldier could carry in one hand. The handles folded flat to save space in vehicles and tanks. In an emergency, a single soldier could sprint out and return with 4 250-round cans. Try doing that with American ammunition cans without destroying your back. Meanwhile, Allied forces scrambled to get their hands on intact MG42s for study. Captured weapons from North Africa, Sicily, and the Eastern Front were immediately shipped to testing facilities. By February 1943, the U.S. Aberdeen Proving Ground had detailed intelligence on the MG42. American engineers were fascinated. This weapon was technologically superior to anything in the U.S. arsenal. They were so impressed that they launched a program to copy it. rechambered for the American 30-6 caliber. This project produced the T-24, essentially an American-built MG42. The project failed spectacularly. And the reasons why are fascinating. The Americans couldn't simply use captured MG42s directly because introducing a new caliber would create enormous logistical complications. They had to rechamber the design for 30-6. But here's the problems. While that seems like a small change, it had massive consequences. American engineers also tried to reduce the rate of fire to around 800 rounds per minute, believing this would improve controllability and reduce ammunition consumption. So they installed a much heavier bolt and stiffer return spring. The 30-06 cartridge is about a quarter-inch longer than the German 7.902x57mm Mauser round the MG42 was designed for, with a slightly smaller diameter. This seemingly minor difference wreaked havoc on feeding and extraction. The first T-24 prototype was a disaster. It fired one round, then jammed, failing to eject the spent case. They cleared it manually and tried again. Same result. They'd created a single-shot MG42, which completely defeated the purpose. The second prototype could fire fully automatic, but suffered horrible reliability issues. During testing, it experienced 51 malfunctions in 500 rounds. Worse, it only achieved about 600 rounds per minute, the same rate of fire as the machine guns America already had. The extremely heavy bolt reduced cycling speed too much while dramatically increasing recoiling mass, which broke gun components after just a few hundred rounds. American engineers worked hard to solve these problems, but by March 1944, they gave up. The fundamental issue was the 30-06 cartridge itself. It was simply too long for the MG42's design. Making it work would require building an entirely new gun from scratch, which defeated the whole point of quickly copying a superior German design. The U.S. military pivoted to improving what they already had. They focused on upgraded versions of the M1919 with buttstock and bipod, and the BR to provide squad-level firepower boost. They also had an ace up their sleeve: the legendary M2 Browning 50 caliber machine gun. These were too heavy for standard infantry use, but Americans mounted them on everything with tracks, wheels, wings, or a deck. The M2's devastating 50 BMG cartridge gave German soldiers plenty of headaches. In the later stages of the war, these guns were absolutely everywhere. However, failing to directly copy the MG42 didn't mean Americans ignored its innovations. In the 1950s, after the war, the U.S. military reevaluated the entire concept of general-purpose machine guns and concluded the Germans had been right. Having one versatile weapon that could fill multiple roles made much more sense than producing separate light, medium, and heavy machine guns. American engineers studied another German weapon, the FG-42 paratrooper rifle, which had excellent ergonomics, compact size, and a good gas system. They combined this with the MG-42's belt feeding system and quick barrel change concept, added some American modifications, and created the M160 machine gun. The M160 became iconic during the Vietnam War. Early versions had reliability problems, and the barrel change system worked better in theory than practice, but over time they refined it. Later M60 variants were solid general-purpose machine guns, extensively mounted on jeeps, trucks, armored vehicles, helicopters, and boats. The M160 had about half the rate of fire of the MG42, but its feeding system was directly inspired by the German design, while ergonomics came from the G42 RH. Here's where the story gets really interesting. The MG42's journey didn't end with World War II. After Germany's defeat, the nation was once again forbidden from having a military. But Cold War politics changed everything. When NATO formed and needed West Germany as an ally against the Soviet Union, they allowed Germany to rearm and establish a new military force. German military planners looked at the most modern machine guns available in the 1950s and realized something remarkable. They'd already designed something better decades earlier. There was one problem, though. The Soviets had seized the technical drawings for the MG42 at the war's end. So the German company, Rheinmetall, had to reverse engineer their own machine gun. Think about that irony for a moment. German engineers were essentially copying a German weapon because another country had stolen the blueprints. This modernization effort produced the MG3. Besides rechambering for the new NATO Standard 7.62x51 Delliers caliber, the MG3 included improvements for modern combat, updated vehicle mounts, slightly better metallurgy and finish. But it retained that brutally high rate of fire. The MG3 even came with 2 different bolts of different weights. The standard bolt produced the original rate of fire, around 200 rounds per minute. A heavier bolt could be swapped in to reduce the rate to about 800 rounds per minute. No other changes needed. Soldiers could customize their weapon based on preference or tactical situation. We need to talk about the Lafayette tripod mount, because this might be the most underappreciated innovation in the entire MG42 system. This mount transformed the same weapon from light to heavy configuration and unlocked capabilities that were genuinely out of their time. When mounted on the Lafayette, the MG could be fitted with optics for precision fire. Buffer springs absorbed recoil, making the gun remarkably stable and accurate, even at long range. The trigger was built into the mount itself, so the gunner fired without physically touching the gun, eliminating human-induced vibrations that affect accuracy. The mount could even enable indirect fire, turning the machine gun into a form of light artillery for area denial. But the deadliest feature was something called the Tiefenführer Automat, literally, automatic search-fire mechanism. This was essentially an analog mechanical computer. Similar to a clockwork mechanism, the crew could preset firing zones by locking in elevation limits. Once set, the mount would slowly and automatically shift the gun's aim up and down, in a preset arc as it fired. Imagine this in practice. A gunner pulls the trigger, and the MG42 automatically sweeps across an entire kill zone, a slope, a road, an open field, walking the burst through the target area without anyone touching the controls. With this mount, the gun sat much lower to the ground, and the gunner could fire through a periscope sight while remaining completely behind cover. Germans sometimes used this for psychological warfare. They'd position the machine gun with the Tiefenfeuerautomat engaged, tie a string to the trigger, and retreat to a safe position. Then they'd yank the string remotely. The gun would sweep across the kill zone, firing on its own with nobody even there. Enemy forces would suppress an empty position while German soldiers watched from elsewhere. The modern Feldlafett mount retained the optical mounting capability, but unfortunately dropped the automatic search fire mechanism, though the MG3 continues to be highly effective on modern stabilized mounts. The MG42 changed machine gun design so profoundly that virtually every general-purpose machine gun developed after World War II incorporated elements inspired by it. The Belgian FN MMH, the American M60, countless others. They all owe conceptual debts to German engineering from the 1940s. Today, the MG3, the direct descendant of the MG42, remains in active military service with over 30 countries. It's typically mounted on tanks and armored vehicles with modern fire control systems that fully hide its high rate of fire. German manufacturing even continued producing original MG42s in the original 7.92x57-900 caliber alongside the modernized MG3, and Yugoslavia created one of the best direct copies as the M53, which served for decades. Think about what this means. A weapon designed during World War II, built around manufacturing techniques meant to be cheap and quick for total war production. You proved so fundamentally sound that modernized versions are still trusted in combat. Over 80 years later. That's not just good engineering, that's revolutionary design that identified principles that transcend technological errors. The Allies tried to dismiss it as wasteful, told their soldiers that lower rates of fire were actually, but they were lying to themselves. Behind the scenes, they desperately tried to copy it. When they couldn't, they eventually adopted its core concepts, the general-purpose machine gun philosophy, quick change barrels, belt feeding systems, modularity. The MG42 didn't just shoot faster. It represented a complete rethinking of how infantry squads should operate, how weapons should be manufactured, and what versatility really means in military hardware. Maybe someday, we'll finally retire these designs. Maybe when we're fighting with directed energy weapons, or something from science fiction, we'll finally move past the mechanical principles the MG42 established. But I wouldn't bet on it happening soon. Sometimes, engineers get it so right the first time that there's simply no reason to change the fundamentals. The MG42 was one of those times. And 8 decades later, the sound of that buzzsaw still echoes across modern battlefields.